Okay, meanwhile, I'm getting the host privileges. Oh, now I have it. Just say it loudly and you'll get it. It will be here. Yes. Yeah, here. Right. So now we are going. Perfect. So again, this is RPKI tutorial mainly. Just give you a quick introduction of what the first word says, manners, mutually agreed norm for routing security. It's not about manners today, so I'll quickly skip to the other things. We'll be doing introduction of the whole RPKI, BGP, why we need BGP and what are the issues in BGP and how RPKI can fix those issues, and what are the other missing parts in RPKI which we can use, which we need to fix with other technologies, for example, ASPA, BGP SAC, or ASCON. So that is a quick overview on that. That is part of the future RPKI. We do have a lab. Everybody will get. I have 20 routers, so hopefully we can share those with each other. It has a live BGP feed. You will receive everything, but you cannot advertise anything, so that you're not going to break anything. So it's strict filtering on the inbound side, on the router side, but you can of course see the whole routing table, and then you can implement ROV as well. So quick introduction. This is based on honor system. The whole internet routing is based on an honor system. Honor system, which we believe is that we respect each other's announcement. We say whatever you are announcing in your BGP, I believe that it is correct. Well, it's fine, but it was fine 20, 30 years ago, but in today's world, it's not. Because it's not about trusting your peers. Of course, we trust our peers, but mistakes do happen. And when such mistakes happen, you have to make sure that you have guards in place to protect your network, to protect their network, your customer networks, and to make sure that nothing goes out on the internet, which breaks the internet as well. But the reason it is based on trust, because when it was designed more than 30 years ago now, there was no built-in validation in BGP. The protocol was designed for information sharing between academia, multiple universities and research institute, and the defense institutes, the DARPA. So there was no reason to have security mechanism in BGP. But there are issues, and the two most important issues we face on the internet every day, every hour. The two prominent one is the BGP route hijacking or prefix hijacking, or we in a more insensitive way we call it hijacking, but a more sensitive way we call it misorigination. Right? So you are announcing something you're not supposed to. So that's misorigination, but of course it is also called hijacking. Route leak is if you are changing the path of some traffic intentionally or unintentionally, creating either a black hole or congestion for anybody else. So these are the two most important issues we face on the internet. This is one of the screenshot from bgpstream.com. There was a service probably 10 years ago or something called bgpmon.com, BGP Monitor, BGP Mon. That service was bought by OpenDNS first and then ultimately by Cisco. But there was a front face of that service called BGP Stream. Of course, Cisco bought the service, the backend. So it is part of their product. So it's a commercial service now. But it has a public-facing website called bgpstream.com, which is publicly available. You can go right now and have a look what is happening. It gives you some incident. It shows some incidents which are happening on the internet. Doesn't show you everything, but of course some incidents are visible. It is one of them. It's from the 10th of September. You can see at what time the incident started. 10th of September 2022, 1652, which is 4:52 UTC. The expected prefix was 185.88.176.0/24, and it was supposed to be coming from AS 201691. But the event they detected, the ASN was coming for 42440, right? So they marked it as possible route hijack or BGP hijack. The reason why they call it possible, because no one knows the business relationship between these two ASs. It could be a genuine announcement, but there is no data available to verify that announcement. I don't have the information to confirm that whether it was a genuine announcement or a hijack. So in the absence of validating information, I would say that, well, possibly it's a hijack. Same is the case with the BGP leak. So the information is available. It was supposed to be coming from one path. Ultimately, it changed the path, creating a leak. It doesn't change the origin. So that is important. Doesn't change the origin. Origin remains the same, but the path changes, which causes a problem. As I said, it could cause a total black hole of the traffic because it's now going through a smallest possible pipe, which cannot handle that much traffic, or the network which is accepting that path is just denying any traffic. So it's just not going anywhere. So as I said, manners, mutually agreed norm for routing security. The reason there is a slide for that is if you are interested in manners t-shirt, you will get it in this session. So you have to remain in this session after the break as well. So, yep, one I'm wearing, it's a polo, and there's another round neck as well, which you will get in the second session. Right, so manners, it's a framework, right? It gives you 4 actions. It has not created a new technology or anything. It just asks you to implement these features. So first one is filtering, and the second and the fourth one is the validation. So we'll stick to the first and the last one, which are the most important one from the BGP point of view. Second and third. The second is anti-spoofing, which we discussed yesterday in the Manners community meeting, if you were there. But it's more of our anti-spoofing. I can give you one hint. Read about BCP 38. If you haven't, it's important. And hopefully you will learn something out of it. Coordination is you have to make sure that if you are representing a network, that network information is available in public databases where people can contact you via email, via phone, most importantly via email. So there should be a contact, your email addresses should be accurate in these databases, whether it is the APNIC, RIR, or peering DB. Right, so let's talk about filtering. The filtering we are talking about today is based on an RFC called 7454. It's a BCP 194, which is specifically designed for the BGP operations. It's the most important RFC if you are in BGP operations. If you manage any kind of transit and peering, please do read that RFC 7454. It is important. I mean, yes, RFCs at times are boring, but the operational RFCs are not boring. I can guarantee you that, because it has a very relevant information. It doesn't talk about the bits and the bytes. It doesn't talk about hexadecimal value. It talks about what are the things you have to implement on your router. So it's very, very basic, but very informative. So BCP 194 is important. So do read that. So these are some of the highlights of this BCP 194, which is prefix filtering, right? So before we do the prefix filtering, we need to identify what kind of prefixes we have to filter, right? So when we say we have to filter on the BGP, there are certain things which we have to block by all means, right? Whether it is coming inside or whether it is going outside, whether inbound or outbound, ingress or egress, right? All these terms, just remember that. For example, any private address space. Who can tell me the RFC for the private address spaces? RFC number? Yes, which? 1918. Yes, perfect. So RFC 1918, 1918. I wouldn't call them the class A, class B, class C private addresses anymore, because now they are classless. So, but private addresses are defined not only in RFC 1918, there are multiple RFCs, because there are prefixes for documentation, there are prefixes for 6 to 4 tunnels, there are multiple prefixes which are allocated for different purposes other than advertising it on the internet. So make sure that you filter those prefixes inbound and outbound. Please do not advertise them. Please do not accept them. You will not see them on the internet, so that is good, but make sure that you do not advertise them. Right, so what should be your loose inbound filter? Loose means, okay, there is still some room for mistakes. So we call it loose because there is still some room for mistakes. What you have to filter, prefixes that are not globally routable, as I mentioned, those prefixes, which is private addresses, addresses for documentation, and reserve address spaces as well for other purposes. Prefixes not allocated by IANA. So IANA is the main body which gives IP resources or address resources, whether it is V4 or V6, to RIRs, and then RIRs further allocated to their members. So if IANA has not allocated anything, please make sure that you filter them out as well. Routes that are too specific, nothing more than /24 in V4. And depending upon what your perspective is about V6, I would say nothing more than /48. But yeah, sometimes it's hard. But yeah, in the V6/48 and the V4/24, nothing specific, more specific than that. Prefixes belonging to the local AS, IXP LAN. If you're connected to an IXP, it's LAN. Please do not re-advertise to the internet. The default route, you're not supposed to be the default route for the internet. So make sure you do not advertise anything, or do not, this is for the inbound. So do not accept anything if you are not expecting a default route. If you are expecting a default route from your upstream provider, that's fine. But if you are not expecting a default route, please filter it out, right? If you don't have the full routing table, and if you believe that if I don't have the route in my table, I still want to give it to the upstreams, that's fine. You can accept the default route. But if you don't want to, please make sure that you filter it out. Strict options. In this case, it means you will not be accepting anything which is broken. Prefixes that are not globally routable, routes are too specific, prefix belonging to the local AS, and XVLAN prefixes on the default route, right? But you make sure that these inbound filters are applied on all the ingress interfaces or all BGP peers. So make sure that you filter them out. Outbound, same thing applies there. Nothing changes. Prefixes that are not globally routable, routes that are too specific, ISP LAN, default route. Max prefix filtering, that is totally up to you. Why? Because it depends upon the platform you are using. It depends upon the router you are using, right? You need to understand how many prefixes you can accept. Max prefix filtering, how many routes you can accept. So some platforms have a default number of routes filter in place already. I think Arista has like 20,000 or something. There is always a in the newer platform, there is a limit of maximum prefixes you can accept. So you make sure that if you do not know the limit, make sure that it's not more than the router can accept. Otherwise, it will crash. AS path filtering. I'm not sure how many of you are aware of the incident. There probably 7-8 years ago, there was a bug in Cisco iOS that if the AS path is larger than 250 hops, if the AS path is bigger than 250 hops, it will crash the router. If you receive a route which has an AS path larger than 250 ASs, it will crash the router. People found out in the middle of the night when their routers started crashing because someone somewhere in the world announced a route with more than 250 hops in the AS path. So yes, that bug has been fixed. Yes. But do not test your routers. Please make sure that you have, because maybe there's someone somewhere testing something and they create a mistake and start advertising an AS path with 500 ASs in the middle. And that was your limit of the router. So don't test your router, right? Make sure that you have a limit, some limit, whether it is 10, 20. I mean, you should not be accepting anything. You should not be expecting anything more than 20 AS path and ASs in the path. That's it. 6, 7, 8 is the norm on the higher side. 20, why it is 20? But anyway, you can accept that. But you can reach the whole internet with not more than 5 to 6 ASs in the path. That should be okay. But to be on the safe side, because people do prepending and do some stupid prepending as well, where they do 10, 11, 12. So you can put an arbitrary number, which is not huge, but not too small. So maybe come up with 20. In my house, I have a limit of 20. But if something goes wrong, that's my house. YouTube will be affected, nothing else. So it's nothing much, but make sure that you do have some kind of limit. Talk to your vendor or read the specification of the platform you're using so you can put the limit in. Now, we come back to the global validation part, right? So the global validation is based on two things. One, the historical way of maintaining validated information. And the second is the future way or the current way, I would say. So let's talk about the historical way. It's called the IRR, Internet Routing Registry. IRR is based on a language called RPSL. I do not remember the RFC for that, but it starts with 2.6 something. So it's very old. So it was designed a couple of decades ago, but it works very well. It's very easy to understand, but it's a very manual process, right? So in that you have multiple objects. Every object has multiple attributes and its values, right? So for example, these are the objects. Autonum, which is autonomous number, route and route 6, these are object. AS set is an object. These are the three main objects. There are multiple objects in the IRR database, but we are talking about the most important ones at the moment. But then the current or the future way of validation is RPKI, right? And the way we use RPKI is in the form of ROA, route origin authorization. We'll come to RPKI at the later stage in detail, so don't worry about it. Right, there are two ways to provide validation information, IRR or RPKI. So I've just explained it. So if you are using Linux or Mac OS at the moment, you can literally run this command right now, right? You can do whois -h whois.apnic.net because you are in the APNIC region, and then put the prefix in, and you will get the route object. You can also put the information of an AS. In this case, it could be AS13335, and you will get the information about the OTnum. That's another object. So these are this is the information you can get from whois, and it is coming in from the APNIC IRR database, right? And how do you add and remove information in the APNIC IRR database? Can anyone tell? How do you update the information in APNIC IRR database? Through my APNIC. Okay, you log into my APNIC, and then go through resource management. I'll show you all that. It's part of the demo and it's part of the exercise. I'll show you all that. So that's not a problem. But just remember, if you need to update, add, update, or remove anything from the APNIC whois database, you have to go to the My APNIC portal, right? Or you email helpdesk@apnic.net, which is not the best way to do it because of helpdesk will do it on your behalf, but yeah, but they can only update whois objects and database for you. They can't do anything about RPKI, so you have to do it yourself. So it's much better that if you are working for an organization who is managing APNIC resources, make sure that you have access to My APNIC. If you don't have it, please make sure you talk to your bosses. You talk to your manager saying, well, why don't I have access to My APNIC? And it has multiple roles, so you don't have to have full access. You can have technical access only, right? So where you can look and create and update whois objects and RPKI objects as well. So what route object explains, right? So it is only telling you the two most important things which we need from routing perspective. There are other important things here as well, but from the routing perspective, we need two most important things. One is which route are we talking about, right? Which prefix we are talking about, right? So it is 1.1.1.0/24, and from where it is originating, the AS number, right? The prefix and the origin AS, that's the route. This is what I want. From the routing perspective, this is all I want. So this information is available here. In My APNIC, I can only create route objects for my own prefixes, right? I can create a route object for 1.1.1.0/24 if that prefix is allocated to my organization. Otherwise, I cannot create a route object, right? Do you see any difference in these two route objects? Wait. Yes, sorry, it was like it scrolled down, so it was not visible. The difference was not visible. So do you see any difference in the data here? These are two route objects. From the routing perspective, they are exactly the same. From routing perspective, they're exactly the same. But there is a huge difference between Both of them. So who can tell me the difference? Source. So one source is APNIC and the other source is RADB, right? And the reason this is very important because the source number one is authenticated source. The source number two is non-authenticated source. And the difference between the two are in APNIC, as I said before, I can only create a route object for the resources allocated to me. In RADB, I can create route object for anything. Literally anything. I can create route objects for resources allocated to Facebook, to Microsoft, to Google against my ASN. Nobody's going to stop me. That's why it's called non-authenticated, right? We always recommend creating route objects in your respective RIRs. For you, if you are in the APNIC region, if you have resources from the APNIC region, please only create route objects in APNIC whos database, nowhere else. But it doesn't mean that someone else will not create a route object in RADB on your behalf. That's another security problem, which we'll discuss later. But don't worry about it for the moment. Just make sure that you only use APNIC whos database for all the route objects, right? Moving on. Routing on the internet. Right. This is how routing works. How? I announce something to the world or to my peer. Let's talk about the peer. I announce something to my peer and my peer announced something to me, right? And how do I accept and how do they accept those announcements? Well, as I said, on the basis of trust, right? Say, okay, fine. I trust my friend. He's announcing something to me. I'll accept it. And my friend will do the same thing. It works. But I do not talk to my friends only on the internet. I talk to 77,000 networks on the internet. So I cannot trust 77,000 networks on the internet. I do not know even who they are. So for me to able to validate this information, what do? I do this. Every time I receive an information, I ask the whos database, the RIR whos database, right? If this information is correct or not. Easy. In theory. Hard to implement. Really hard to implement. Why? Because if I'm talking to you, if I'm talking to one person, right? Probably you are a large ISP. I am a large ISP. You have probably 200 routes. I have 200 routes, right? Maybe you are a very large ISP. You have 1,000 routes. I am extra large ISP. I have 2,000 routes, right? But it's still a finite number, right? 2,000, 1,000. You gave me that list. I verified that information from whos database. I said, yep, everything you have given me is accurate. I will update my filters. Now, extrapolate this information to 77,000 networks, right? How many routes are there in the routing table at the moment? Depending upon where you are in the world, it's around 920,000 routes. Almost hitting just on the V4 side. And there are 125,000 in the V6. So if you combine them, you already have more than 1.1 million routes. You cannot build a filter for 1.1 million routes. That is straight away 1.1 million lines of code in your router. Straight away. If you are verifying every route, that's 1.1 million. It doesn't scale. It's very hard. So, it's validated. But then on top of it, You have non-validated information coming in from RADB, from AllDB, from other IRRs, which are globally available, but you cannot verify those information. But if you stick to RIRs only, 5 RIRs, okay, I'm only gonna query these RIRs and nobody else. Still, you're talking about close to a million lines in the routing table. Sorry, in your on your BGP configuration. So these are the problems. Some IRR data cannot be fully trusted. So accuracy is a problem. Incomplete data. Not every route in the global routing table has a route object. Forget about valid. A lot of routes in the routing table doesn't even have a route object. So how do you verify that information? Do you not accept that information? Do you not accept that route? Well, there is a business concern and there's a technical concern. You're from the technical point of view would say, well, I'm not going to accept it. But the business manager will come in. I said, like, this is my customer. You have to accept it. Here you go. It doesn't scale. How do you do that? Inaccurate information, incomplete information, and lack of maintenance. The reason it says lack of maintenance, you will find route objects created in 1995 and have never been updated since then. And it has changed hands so many times. That route doesn't exist, but the route object still remains there. For example, if you look up RADB route objects, only RADB route objects, there are more than 1.5 million route objects in RADB alone. More than that. So, I mean, there are not that many routes in the routing table, but there are more route objects in the RADB alone. So it's lack of maintenance. Whoever created it, because it's unauthenticated, anyone can create it and they just forget about it. In last APNIC, I did the presentation in routing security SIG, where I showed that some routes on the available in the global route table has up to 30 route objects associated with it. 30 route objects. Only one is valid, 29 are invalid. So that is the level of inaccurate information. Now, moving into RPKI. So, what is RPKI? What is RPKI? Any ideas? Guesses? Okay. Can anyone give me the example of PKI? Public key infrastructure. Web PKI, which is HTTPS. Simple example. Web PKI, every time you log in, you go through the HTTPS. It is a form of a PKI. The only difference is that PKI technology is now implemented towards in the routing. That's it. That is the only difference. It is still private public key, just like in Web PKI. Exactly the same. Nothing changes. Terry, you want to add something to that? Okay. Yes. Yes. I mean, just keep it keep it light. I mean, I'm not teaching anything. I always say that. I don't teach. It's just I have learned few things in last 15, 16 years. I'm just sharing that, right? So I'm not a teacher of any kind. I'm not an instructor of any kind. I'm just sharing some knowledge, right? I do not run an operational network, and it's been 5 years now. I do not run an ISP. So maybe I don't know some important bits which you know. So please do share it with me so that I can update my knowledge as well. It can help me understand a few more things, right? I do a big and large network to collect routing information across the globe. I have route collectors in many places. So I have that information. I collect the routes. I can show you that one. I have multiple BGP routers all across the globe, right? And you will be testing on those. You'll be working on those in the second session. So that I know. But if you're an ISP and you can say, well, there's a problem in our ISP. So you can tell me about that, which will help me understand more. So RPKI, it is about the resource PKI, right? What are the resources we are talking about? IP addresses, irrespective of the V4 or V6, IP address and ASN. That is it. What it does, it simply create a certificate with a private key and make sure the public key is available for you to verify that the certificate is valid. Simple, just like you do it in HTTPS, just like you do it in Web PKI. It also follows a hierarchy of trust. So you can verify that certificate with the root certificate. And who are the root certificate holders? Them. Right? You can trust Epinik. Right? You can trust RIPE NCC, you can trust Aaron. So there are 5 trust anchors. All 5 are IRs. Right? And then this is the hierarchy of trust. You say, well, I have signed this information. I have signed this route with my private key. You can verify this with my public key. But if you want to further verify this key pair, you can verify through the Epinik key. And it satisfies the PKI trust that works. A short history. RPKI is not a new technology. It's not a news to anyone anymore. It's not new anymore. Operated since 2008. So, thank you so much for grabbing one mic. So it's not new. It's been there for 2008. Yes, it was very experimental at that time. I still remember going to Apricot in 2016 when Mark, who introduced me, implemented it in his network. 2016, 2023. So it's not new. People have been implementing it for a very long time. Yes, there were issues, a lot of issues at that time. The issue of, because we'll discuss how the RPKI works. There were issues on the vendor side. There were issues on the RIR side. There were issues in the middleware, I would call it right now, but we'll explain what this middleware is. There were issues in the middle as well. So, but right now, it's very mature. Mature enough for everyone to implement it in your network, in your operational network, without causing any problem. Okay, whenever you hear the word crypto in routing, it's a different crypto. It's not the Bitcoin crypto, right? So just FYI. Chain of trust, I explained a moment ago. It is the same. Now, RPKI is a framework. You need to understand that, because when you tomorrow, hopefully you will come to the routing security SIG, you will learn about another object in RPKI tomorrow. So there are multiple objects you can have in RPKI. ROA is one of them. ROA is not the only thing in RPKI. ROA is the first one, I would say. So resource route origin authorization is an object. Again, just like we have it in IRR, who is database, multiple objects, route objects, autonom object, and AS set object. Here we have ROA, route origin authorization. That is the signing part. This is the certificate. But you have to use the certificate. When you use that certificate, that part is called validation or validating. right? So there are two part of RPKI. One is creating certificates or creating objects. You can create objects for multiple things. Right now, we're only creating for resources, for the routes. So you're creating objects, and then you have to verify those objects. You have to do two things, right? First thing is you create ROAs. So what is a ROA? What were the two most important things in a route object? Prefix and origin, right? ASN. Two important things in the route objects, in IRR route objects. Same thing here. Two most important things in the ROA, which you need. There's a ton of information in a ROA object. You don't need that. I'll show you what's there, but you don't need it. You only need two things. One is the prefix. Second one is the origin AS. That's it. LIRs, which is an ISP, which is local internet registry, can create a ROA for their resources. Multiple ROAs can exist for the same prefix, just like multiple route objects can be for same prefix, right? Same thing. ROA can overlap as well. We will show you that. Okay. So, but the most important bit is only and only you can create ROA for your resources. No one else can. It is authenticated and there is no RADB in the RPKI. So nobody else can create route objects for you or ROA for you. So three things you will see in a ROA. One is the prefix, right? And how long is the prefix? /24, if you remember the prefix filters in Cisco and Juniper, you can define the length of prefix. You can say, well, anything between a /24 to a anything between a /16 to a /24. Create one prefix filter for that, right? You remember? Right? In Cisco and Juniper or any other, I mean, forget about Cisco and Juniper, any other vendor, you can create filters on the basis of the length of, the range of the prefix length. You can say from /16 to /24 in the V4 side, /32 to /48 in V6 side. Allow everything in the middle. That is a range of your filter. You can do the same thing in ROA. Okay, you can say /22 up to /24. Everything is allowed in the middle from this origin AS. From this origin AS, everything is allowed. Just to make it easy, this is a existing ROA. This is how it looks like. This is what the data is in the .ROA file, right? What it says, the ROA version is number 0 when it was signed on 30th of December 2022. ASID is the origin AS, right? That's my AS 139.038. IP addresses allowed in that ROA 103.138.210.0/24. The second one is just an experiment, so don't do it in your network. /32. I just wanted to see what you can do with it. You can do anything because it's your resources, right? But don't do /32s. And the V6 side, I have multiple as well. So you can create ROA, anything within the ROA, as long as the resources belongs to you, right? And if you want to read the ROA file, and if you have Linux or Mac OS, you can install RPKI utilities. Go to GitHub and search for Pi3 RPKI utils, right? You will find that it's easy. You can open up any .ROA file coming in from the repositories. Right. The second part So let me show you a few things to help you understand what I'm talking about. Right. Is it okay so far or is it too much? Yes, no, go away, not interested? No? Why I'm not sharing the screen? How many of you have heard about this website? rpki.cloudflare.com, right? I do not work for Cloudflare, but yeah, it's a nice one, right? So, um, how do you want to? How do you see dot ROA files of your network, right? So, give me an example of ASN. Any example of ASN? Come on, give me your ISP ASN. 38022. Okay. So these are the ROAs your ISP has created. Well, a lot of them. So what I do is, because I'm exploring here, I go and I open up this folder, right? And I can see all the files associated with this ASN. All the files. I'm not specifically saying ROAs because there are two other types of file in that folder. So I can see all the files associated with my ASN or his ASN. So there are three types of file. What are those? .ROA, .CRL, and .MFT. .ROA, I explained what they are, but there are two other things. .CRL and .MFT. .MFT is the manifest. Is the manifest. Manifest tell you that what is actually. So first thing you read is the manifest file. So when someone comes in, well, of course, the software, when it comes in and verify this information, they read the manifest. Say, okay, fine. What I should be looking at in this folder, right? So the manifest for right. So this is the output of a manifest file. Okay. From the same utility, which I told you before, which is Pi3 RPKI utils, you can also open manifest file. What manifest is telling you? That how many files you should have in this folder. So these are the list of ROAs you should have. If you have anything more than that, it will not accept it. Okay? So it is just how RPKI works, right? And what is the CRL? It is a certificate revocation list, right? Once you create a ROA file will show up. But when you delete a ROA, of course, the file will be deleted if it is associated to one ASN, but it will be added to the CRL as well with the serial number. It will tell the software that these rows have been eliminated. So if you still see the .roa file, do not do anything with it. Just do not accept it, because that ROA, that certificate has been revoked. Okay? So you always see three kind of files in your folder associated with your ASN. In APNIC, every RIR, this is the structure of the RPKI, every RIR, every ASN has a specific folder. Of course, it doesn't have the AS number, it is a random number, but every ASN has a specific folder, and in that folder you will find all the ROA files, one CRL and one manifest file. Okay? I know that is boring, but it's important to understand how RPKI works, right? Maximum length. What is maximum length? If I may request Terry to explain a little bit on that one.
So when you're looking at this database of origin ASNs maps back to prefixes, you can see here the ASNs, when you consume this data, are the supposedly primary key, but when your router hardware goes to look up for ROV, it actually works the other way. It actually looks for the most specific prefix. Okay, in that case, it will look in that range, 22 to 24, and try to get the most specific route out of the database, and then maps that back to the ASN. So you can, if you want to, have just a /22 and an MSA of 22. That way, no one can actually, I suppose, de-aggregate your SuperNet and impersonate you at /23 or /24. Or you can just say, well, I'll do the /22, I'll do another ROA for one of the /24s, and they're the only two routes you're expecting. But the algorithms are very specific with validation. It goes looking for the most specific prefix under that top level, under that /22, and it very much has to either fall within that range to be valid, or if it's out of that range, it actually becomes invalid. Even if the ASN is your ASN and maps correctly, it will not validate, will it?
Yes.
So again, think of BGP, the way it looks at routing in general. Every time you're looking at route selection, most specific route wins every time.
Now you can correlate what exactly Terry said, right? So if you have a maximum length of /24, right? It's starting from /22 to /24, right? It's starting from /22 to /24. You're saying this is the range. Everything marked in green will be accepted. /22, of course, will be accepted. /23, 2/23 will be accepted. 4/24 will be accepted. Okay? This has nothing to do with RPKI for a moment. You have been doing this in your prefix filters from the very beginning. If you have done anything on Cisco, Juniper, or Arista, or any other vendor, everyone allows you to do that. You can create a range of prefix length. You can create /22 up to /24. So if you have a /22 in V4 and you create a maximum length of /24, everything in green will be accepted. Anything in red, of course, will be dropped. Right. So, okay. Here is a ROA. 193.0.24.0/21 with AS is 2121 and maximum length of 21. So tell me what will be accepted. Right? Accepted. Nothing else will be accepted. Why? Because the maximum length is also /21. It is saying only /21 is allowed, nothing else. Nothing else. If I just change the maximum length to /24, everything is accepted. See, if I create another one with maximum length /24 with /23 as origin, I add 3 more announcement. I add 1 more announcement. So it is what I'm doing. I'm making a very strict, I've made a very strict choice that I will only create a ROA for whatever I'm announcing. Okay. And it is the best current procedure or operation procedure or BCOP or BCP. There is.
Yeah. I was going to say, obviously, if you make your policy too broad, you're actually open to someone de-aggregating and attacking you with your own ROAs. So if you make it really specific, and these are the routes these routes are advertised by your ASN, anyone who tries to de-aggregate and go outside that policy, RPKI validators are just going to reject the routes outright.
So can anyone tell me how is that possible? What Terry explained, very important bit. Can someone give me an example? Yes. Absolutely. Okay. So let me just repeat what he said is you have a max length for /21 up to /24, right? But you are only announcing right now 1/21. You're not announcing anything else. You're only announcing this one, right? But in ROA, the max length is /24. Okay. It means you have a very loose filter. If I am a bad actor, what I can do, I can originate a /24, as he said, from his ASN, right? Prepend it with his ASN, because the origin, this is only origin. It's had nothing to do with the path. It's only origin. I just prepend it with his ASN and start originating a /24. If my ISP is lousy and not filtering anything, they will accept it. And I have just created a hijack with a validated ROA. It will be accepted by everyone because the origin AS is the real AS. And because he's not advertising it, and the more specific wins. Yes. Yes, go ahead. Yeah.
If I have a /21 in this example, and I create 2 specific ROAs for 2 /22s, and then I announce a /21, what would be the status of that /21? I don't have ROA for that. I have 2 /22 ROAs.
Not found, unknown.
So, yeah. The reason why I'm asking it is also to remind the network operators that please create a ROA for your aggregate first to cover the whole subnets, and then no one can actually take some of the advantages of
yes.
SuperNet.
So I mean, it's a very good example. Okay. So if you follow this debate, there's a lot of controversy in this RFC, which says that only create ROA for what you announce. It is good advice, but it is slightly off from operational practices. The advice, there is nothing wrong with the advice. Advice is security-wise, this is appropriate advice. But how operations works, how network works, it doesn't work like that. So that is the problem. So we'll come to that when we do the route origin validation, right? But that's most important bit. I mean, that's how we started ROA, the rollout of ROA, saying create the whole range, because that was the easiest way at that time. Still, it is the easiest way. And then you do negative ROA. We'll talk about that as well, right? So moving forward, okay, we have discussed this in detail. RPKI certificate structure. I mean, I want to move forward so that when we come back after the break, we can straight go to the exercise. Right. So this is how the structure works. There are 5 anchors, trust anchors, right? 5 trust anchors are ARIN, APNIC, RIPE NCC, LACNIC, and EFRINIC. 5 RIRs, 5 trust anchors. Every trust anchor, of course, is an RIR. Every RIR has members, right? So every member can create a ROA. No trust anchor or RIR can create a ROA on your behalf. Okay? You have to do it yourself. In theory. Practically, they are creating ROA for you because because it depends upon what model of RPKI you're using, whether you're using self-hosted or hosted with the RIR. If you're hosting it yourself or you're hosting with the RIR. If you're hosting it with the RIR, they are creating ROA on your behalf. Okay? The mechanism is fail-safe. The mechanism is very secure. But of course, if you're giving permission to our APNIC, then the ROA is created by them on your behalf. Of course, there are security mechanisms, as I mentioned. You log into your MyAPNIC account, it's authenticated, it's validated, and only then you can create a ROA, but it is created on your behalf by APNIC. If you want to create another security layer, you said, APNIC, thank you so much. I will host it myself. I will host the CA, the certificate authority, myself. And you take the certificate down and you host it inside your network. Don't do it if you don't know what you are doing, because people have done mistakes and it creates problem for their network, right? After 15 years of my operational experience, I have no problem trusting APNIC. So trust APNIC on giving them the certificates, the certificate authority of your network. No problem. So the hosted to delegated, this is what it looks like. It is the RIR hosted. I will show you the details of the RIR hosted because my own network is hosted. The CA is hosted with the RIR, which is APNIC. And any member can opt to host their own CA with themselves. So it's self-hosted. Right. So hosted RPKI, RIR hosts a CA and signs all ROAs. Automate signing, key rollovers, everything happens magically. You don't have to do anything, right? Allows you to focus on creating and publishing ROA. You focus on what is important. You pay membership fee, they will handle it. Simple as that. If you do delegated, they are not going to give you any discount. You still have to pay the same membership fees. So
if you are getting address space from multiple RIRs, then I'm afraid you're going to have to do a delegated model. But
yes.
If you're that big, i.e. a global company, you're probably already investing the time in doing that anyway. But for small to medium-sized networks, you're going hosted in MyAPNIC. If you don't mind ticking the box saying just use my BGP routes, you can sign your ROAs in 5 minutes in the portal. It's that easy.
And if you are big enough and you have resources in multiple RIRs, you can grab any of their RIR and say, give me an API. I don't want to host it with myself. Give me an API. I will do it through an API. But that is a long discussion. Of course, if you have resources in multiple RIRs, the best way is to do it delegated and do it yourself. There are only 2 softwares available at the moment who can help you with the delegated RPKI. One is from the Dragon Research Labs, which is RPKI Toolkit, which hasn't been maintained in 10 years. And the most updated one is Krill, done by NLNet Labs. It's a non-profit organization. It's very well maintained, works very well. It's been used by many operators. Right. So creating ROAs. So let's go to the creating ROA part first. Now, so let me log in to my APNIC and let's see if it's still valid. My APNIC. Yep, I am still logged in.
We should mention that if you are planning to do any signing of ROAs, you need to set up multi-factor authentication with APNIC. That's the top T. So something like Google Authenticator or a similar key generator. That way you have out-of-band and multiple sources of authentication. That's the only way we're going to let you do ROA creation in the portal. So if you don't have that set up and you want to do some signings today, or at least look at it, I'd suggest setting it up in the break, especially if you want some help with us after the break to do that.
All right. So I have just logged into my APNIC with two-factor authentication. So you need two-factor authentication before you can do anything with the RPKI. Which is easy because I think two-factor 2FA is available everywhere. So you have to do it anyway. So now I have logged in. Now you have to go to, if you have not enabled RPKI before, you have to go to RPKI. If you have not enabled it before, if you haven't done this already, then you don't have to do anything. When you come here, you have to press a button which creates a certificate and it remains with the APNIC. Right? So because I have already done it, so it will just show you that how many resources are covered under that CA. These are my resources. This is my personal APNIC account. So all these resources are there in that CA, covered under this CA. So once that is done, then I go to the route management. Okay. In the route management, I can create. So these are the ROAs I have already created. This is an experiment account. So there's a lot of garbage in this, right? So don't worry if you say why there is 429496000 there. It's not doing anything. I only use it for research purposes. So for this prefix 103.138 is only for the research purpose. The other AS is for my home network, so I don't touch it. It's only one ROA and it's working very well, so I don't do anything with it. So, but with the 103.138.210, you will see that in the lab as well. It's an experimental one. I do a lot of things with it. So what you do, you have to define only three things. One, prefix, and the prefix which only allocated to you. That's it. You cannot do anything else. Origin AS, and third is maximum length. Okay. So when I click here, it's just overriding it. APNIC by default gives me the resources I already have. I cannot type anything else. So it says either you select this or select this. So I have selected this one, right? 103.138.210.0/24. Now let me try to make it 212. Right? I can add anything I want. And the origin AS, anything. I can write anything. Because what is authenticated? The prefix. Since it's a /24, well, it's too big. It is a /24, so I can't go any smaller than that. Can I? I can. Right? but I should not. There's a difference between what the protocol allows and what you should do. Right? Now, I don't want to create a whois object because we are doing an RPKI one. So I don't want to create a whois object, because if I create a whois object with this one, this ASN will get a notification. This AS owner will get a notification and they'll say, who is this person or node? What are they doing? So I don't want to do that, right? So I just unclick it and I can create ROA. Let's see. Why? Because that prefix doesn't belong to me. Okay? That is the authenticated part of the RPKI. I can only create ROAs for my own prefixes. So what I will do, I will come back and be a nice person and fix it. Right? And I said, okay, fine. Now everything is good. Go ahead. It says creation request has been added to the pending queue. Click pending queue for. So every RIR has a different publishing mechanism. APNIC publishes ROA after every 10 minutes. So they collect all the requests, put it in the queue for 10 minutes, and then publish it all together. Right? So in the meanwhile, let me show you another thing. So 103.138.210.0/24. And what I will do, I will go to the right. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 rows, right? So 12 rows are there in my repository associated with me, with my network. So there are 12 of them are there. So I have created another one. So it will take some time. There's one pending request. I can just view it. But of course, it's pending because it will take some time. Right. Any questions so far? Anyone? How many of you have logins to MyAPNIC? What happened? Where did it go? Oh, it's not even showing. 210/24. Oh, no. Did I do anything? Oh, when did that happen? Why do I need to recommit? Well, see, I told you I learned something new today. It wasn't there just a week ago. So now I have to double commit it. Yes. Okay. Good to know. So even when I created it, it didn't happen because you have to submit a commit. Now it is showing here. So you can come and see what is the progress. Of course, the request is in the queue. It will take 10 minutes to be created. Once it is created, once APNIC publishes it, you will see a new ROA file here. Okay. If you can tell me why there will be a new ROA file, you will get a gift. Come on. Sorry? Okay, so in APNIC, what a ROA file, not a ROA, what a ROA file represent? Huh? Okay, it is a signed object. Okay. Okay, let me give, okay, that's a tough one. Okay, I accept that's a tough one. It's too tough. So let me make it a bit easy. So let me show you more details. How do I share? Okay, now we are going towards the interesting part. So you will love it. Okay. Is it too small? Yes, it is. Is it okay? Okay to everyone? Okay. Oh, I can't see my screen. Yeah, okay, I can see now. So what was it? So I made it too big. Sorry. Is it still okay? Yeah, it's still okay. Right. So this is my folder, and these are all the raw files, just like they were there in the web, on the web, right? So what I do, I just read it from here. So this is the Pi3 RPKI util. And right. So this one. And this one. There are two raw files, and let's read another one. Every row, I have opened 3 raw files. Tell me what every raw file represent. Let me open more and tell me what every raw.roa file represent. I'm opening more, so it is crystal clear in front of you. Now it can't get any simpler than that. Yes. Absolutely. Yes. It creates in APNIC, it creates .roa file for every origin AS. Because I have created a ROA for an absolutely new AS. That's why it will add another .roa file. That doesn't happen in Aaron. Aaron creates one .roa file for every ROA. Okay, so it creates a separate file for every ROA you create, irrespective of ASN. But in APNIC and other 4 RIRs, other 3 RIRs, it happens that that each ROA file is created for or on the basis of origin AS, not on the basis of the ROA you have created. Okay, so that is the difference. So yes, you will get a gift. Thank you. Great, good observation. So just remember that when you're looking at the ROA files, that ROA file is associated with the origin AS, because I have, and that it means it shows I have 12 origin ASs in my certificate authority, because it is for experiment. That's why I have too many. You should not have that many. You should have only 1 or 2 maybe. So that's how you create a ROA. It's time to take a break. When we come back, we will quickly go towards the route origin validation and the exercise. Okay. And I'll bring the t-shirts as well. So thank you so much for that. I will come back.
Recording stopped.
Hello, everyone. Back. So just to make sure that I was not bluffing, so here are the gifts. You will get one if you answer it correctly, right? So, and you will get a t-shirt as well. Now, where were we? All right. So we talked about the first part of the RPKI, which is the creating ROAS and how you create ROAS and using MyAPNIC and what is in the ROA, what is in the manifest, and what is in the CRL, which is the certificate revocation list. So that we have discussed, we have seen it with ourselves, that what content is there in those files, right? And now we move into the second part, which is the validation, right? To validate the information you have created in ROA, you need a third-party software called validator, right? In journal, it is called validator, but in the RPKI term, the name is relying party software, right? So now we are talking about the validating the information we have received, right? Software that creates local validated cache with all the valid ROAs. Download the RPKI repository. This is the purpose of the validator or the relying party software. What it does, it sits in the middle between the router and the RPKI repositories or the trust anchors. It sits in the middle, get all the information from the trust anchors, the valid ROAs, get all the information, create a cache, and then send it to the router, right? It receives all the information from the repositories. And what are the repository? I just showed you through the web, right? All the .roa files, all the files. It gets all the file, open it up, reads it, create a cache, and send it to the router. Okay, so the router doesn't have to decrypt anything. So there is no burden on the router to read the ROA files. Everything is readable by the relying party software. So this is how it works. The validator sits in the middle. It talks to all the trust anchor locators and repositories, and then get all the information, create a cache, and then send it to the router. So the information it passed on to the router, it uses a different protocol. That protocol is called RTR. And the abbreviation for that RTR is router to router. Simple, right? So it gets the information from the repositories, open it up, create a table, and then send it to the router through RTR protocol. Okay? Do you understand this diagram? The flow of information? And this is how it happens, right? So all the information you get from the validator is now added into the RPKI cache in the router. And then every time a BGP update is received, router will check that update against that cache and find out whether it is valid, invalid, or not found. Right? It will give you 3 results all the time. Every time there's a BGP update, the router will look up the cache and say, okay, the route exists in the table. Yes, valid. That route does not exist in the table. Not found. And third one is, well, the prefix exists, but the origin as an AS doesn't match. Invalid. The AS and the prefix exist, but the maximum length doesn't match. Invalid. Invalid in both cases, right? So there can be only two cases where it can be invalid, right? So either it can be invalid because of the wrong origin AS, or it can be invalid because of the wrong max length. Okay? Three categories: valid, invalid, not found. Valid is simple. Origin AS, prefix exists, tick. Not found, easy. You looked up, nothing is there, not found. Third one is invalid. It looked up, the maximum length doesn't match, or the origin AS doesn't match. In two cases, invalid. These are the 4 relying party software or RPKI validator in journal. Okay. One is Routinator. It is run by, it is created by an organization called NLNet Labs, based out of Amsterdam, Netherlands. There's the second one called RPKI Client. It is based on OpenBSD. It's an open source project written in C. Of course, you can use it in different Linux distributions. You don't have to use it in OpenBSD only. You can use it in other Linux distributions as well. It has a portable version as well. Octo RPKI is based on, it was developed by Cloudflare, but now maintained by the community. Different people in the community are maintaining it. It has 2 different versions. One is the validator, another one is the RTR. So Routinator, an RPKI client, has built-in validator and relying party and RTR client. Octo RPKI has disjoint RPKI client plus RTR. So you can use Go RTR or Stay RTR. There are multiple versions of that. And the fourth one is Ford. It is maintained by Nick Mexico, which is, of course, in Mexico. It's also a open source project. It's written in C, is very stable. At least in our network, in my network, I use Routinator and Ford. RPKI client is also very stable, very robust. But right now I'm using Routinator and Ford. How do you configure the validators? It's very, very easy. If you have done anything ever on Linux, it's very easy. You just, because all these projects are in GitHub, you just clone the GitHub repository and follow the instructions. It's like literally 2 to 3 lines of instructions and it will be installed. This last line is not true anymore. Just going back a little bit, up till last year, there was a issue when you install a relying party software. You need to add trust anchor locators, TAL, T-A-L, trust anchor locators. It is just an address, nothing else. It's just an address. That address tells you that where are the repositories, right? So you have to add that value, and then relying party software will know, okay, this is where I have to go to find all the repositories for that RIR, right? Up to last year, Aaron was not automatically added in the relying party software up till last year. And the reason for that was you have to accept the terms and condition first before you can move on to the adding to the before you move on and add the trust anchor locator in your relying party software. That restriction has been removed. Now you can add all 5 of them automatically. You don't have to do anything. So Once you install it, this is the simple command. You just run routinator and point it to the server IP, and that's it. Nothing else. It's so easy. Right. In the past, you were supposed to do this. Not anymore, as I said. You don't have to do this anymore. Aaron, that was the RPA, which is the what was RPA? It's a resource. It was an agreement, relying party agreement. Yes. So that you don't have to do it anymore. It will be installed automatically. So that is gone. All these restrictions are gone now. So let me show you, because I have already installed them. So I will show you what is happening. Right. So this is routinator I'm running here. So it will simply show you that the routinator is running. It is because it has IPv4 and IPv6. So the RTR server is running on both v4 and v6. You can point to port number 3323. 323 is the default RTR port. So I'm running it on 3323. So we can do it on both v4 and v6. So it's running. If you want to point your lab router towards it, because I do experimentation here, so it's not reliable. If you want to point it towards this routinator anytime, you can do it. Same is the case with Fort. So you can see that Fort validator is also working. All the information is there. You can point it to any either the v4 or v6. So it is only taking 500 megabyte of memory, very lightweight. Both of them are very lightweight. It doesn't take a long time to build the cache. It doesn't take a long time to update it. So it's pretty decent, both of them, routinator and Fort validator. So these are the two running. Share again. So as I explained, how the validation works, ROV. You create ROAs through certificates, of course. Then that information goes to the validator or the relying party software through a protocol called, there are two possibilities of those protocol. Either you can do with rsync or RRDP. There are two protocols. You can use either of them. By default, it uses RRDP first. If it doesn't work, it falls back to rsync. So you do RRDP by default, and then you can get all the repositories from the trust anchor locator you have installed in your relying party software. You get all the information. The validator then read all the raw files, verify it with the manifest, check if there are any revocations in it, do all the validation, create a clean cache, right? It creates a clean cache of route, origin, maximum length. It create a table. And then that cache is passed on to the router through which protocol? RPKI, RTR, router to router protocol. And then once the router has that cache installed in the RPKI table, every time a BGP update is received, it look up the table first and then make a decision whether to install it, remove it. You can make the decision on your own. It will only mark it first. So the RP, it will not do anything unless you tell the router to do it. It will only mark it, whether it is valid, invalid, or not found. What to do with these routes, you have to decide. Okay, and we will decide. BGP validation, this is how it works. Okay, I explained this right. So this is the last bit. Let me explain. And if you are following APNIC talk or polycystic mailing list, then this has been discussed on that. So there was a discussion where it says that if I want to override the ROA for XYZ reason, if I want to override the ROA, there is a possibility through slurm, SLURM. I can create a local file which can override the ROA. Or if the ROA doesn't exist, I can just create an entry into the slurm file. We'll come to that one. But here is the lab. As I said, we have two relying party software, Fort and Routinator running. And we have 20 routers. All are running FRR, free range routing daemon on it. It has BGP. You will 3, 4, 5, 6, 7, 8. Okay, we have more than 20. So we need to find a way to make sure that we can distribute it properly, because yes, so this is how it's going to work. You will be able to SSH into each box. Every box has a host name. You can SSH into that. The user ID password, I will show it here. You can log in, and then you will be able to do BGP peering on the LAN side. There's a 10 dot something IP there. You can do the BGP peering on that side, eBGP pair, and you will receive the full routing table. Okay. Once you receive that you can implement prefix filtering, number one, and number two, you can enable RPKI. Once you enable RPKI, you point to the validators. 2 of them are there. And then from there, you can make a decision what to do with the invalids, what to do with the valids, and what to do with the not founds. Okay? Simple as that. For example, this is just a demo setup. You will receive the information from the AS is 139038. Every router has its own private AS. You will pair with your private AS. It goes from 64512 onwards up to 20, at 20 AS under that. Then, for example, you are receiving this announcement, which is an invalid, 64870 from AS 64870, and the prefix is 2139023.0/24. You will receive it. It will be marked as invalid. Then you have to decide that what to do with it. Okay. This is how you add. This is how you point to the validator. These are the commands I'll show. Let me first show you the details. All right. So here is it. You will be able to just point, just SSH to any of these boxes. Okay. So you have to come up with a plan. Terry, we have to come up with a plan so that everybody can have access to the router because we have more than 20 people. 20 routers. Yeah, buddy. Two. Yes, two. Okay. So pick one. So what are you picking? Router one. Okay. Router one is your. You can take one router as well. 2, 3, 3, 4 and 5. 4 and 5. Then it starts from 4. Okay. 6. You can do with, I mean, by that time we should have 6. You want to take the right at the end. Which one you want to take, router? 7? Huh? 7. 8. No. 9 together. I mean, we still have half of them. 10. 11. No. Okay. We have plenty of them. Well, we're good. Just don't forget which number you have. Okay. Because I don't remember now. Okay, so what happens once you join, when you log in, what you have to do, because you will log in with your user ID. So you do sudo and then vtysh, and it will log you into the router directly. Okay, so there are two interfaces. One has a public IP, one has a private IP. You cannot pair with the public IP; it will not work. You can only pair with the private IP here. So nothing is enabled. It's a blank configuration. So you have to enable. So you have to do the BGP configuration yourself. Okay, and then you pair with the. And this is the information, right? So I have already configured the your other end. The peer has already been configured. Your end is not. So of course, you need to do that. SSH. So for example, you do SSH. What is the ID? Sorry. Let's say 19. Let me pick 19, right? So I do pick 19, right? Just follow me here. I do apricot 2023 @ this, and I just enter. It will ask me to add that. Once it is done, I will add the password, which is 202 minus, which I entered incorrectly. What? What happened?
Sir.
Yep,
They're asking for the procedures.
that's fine.
What's required for us? Because we already logged into the router. I see
Okay,
it's-
let me show you. Okay, I am on router number 19, okay, because no one is using router 19. So I'm on router 19. So first thing, I have logged in. What I do, I'll log into the router console, which is sudo vty-sh. I give the password once again. Here it is. It's blank. Nothing is there, right? So first thing, what I have to do, I have to configure the BGP, right? First thing what I have to do is, what is the IP? 1040.96.22. And what is the peer IP? 10.40.96.100. So let me see if it's reachable. Yes, it is reachable. So it is working. Now the second thing I have to do is configure the BGP. So router BGP, and what is the AS number I have for router 19? 64530. So I pick it up, say 64530. And I do that. Okay. And then I set up the router ID. And the router ID I want to set up is the private IP so that I know I can tell my peer who is coming in. Okay. Then I do the neighborship with 10.40.96.20, sorry, 100, and remote AS is 139038. This information is available here, okay? This information is available here, 9600, 139038. And I do this, right? But nothing will happen. It is giving me two errors. It is saying policy violation. Why? Because I have not created any policy to receive anything or advertise anything. So I have to create prefix filters. Okay. So I have to come out of the BGP configuration and I do IP prefix list. V4 allow all permit all, and that's it. Any, not all. And then I go to router BGP 65, what was it? 64530, 64530. And I go to address family IPv4, neighbor 10, prefix list V4 allow all, in. I'm not advertising anything. Okay, in. And bingo, all done. See, all of a sudden you have 51,000 routes. I will update it. 190,000, 239,000. And it will take some time to update. That was it, simple. So BGP session has been established. And if I go to my peer router, which is here, oh, some of you are good. You already have established. Here, you create a prefix filter and then you go to the address family and you apply that. So now I think it has converged properly. So I'm receiving 900,000 routes on V4. Okay. What? We have lost internet? Oh. No, it's still working. Oh. Happened with that? Dead?
I just moved the microphone F tab because I'm getting
Yes.
lazy in my old age.
Yes, okay.
Sweet, cheers. And then I think.
Wondering if anyone's curious and they've checked their own network's routes in this exercise, because it's a live table, isn't it?
Yeah, it overwhelmed the router.
Oh, no, you have you?
Yeah. So it's okay. So let me explain the mistake I made. So you haven't done anything wrong. So what happened? It is accessible, not accessible from here. And what happened is because there are two interfaces, right? So you are accessing it from, one is the private and one is the public. So you are accessing it from the public interface, right? The moment you enable the BGP, you start getting the routes from the private interface. That I did the same mistake, which I was telling you not to do it. There is a default route in it. So now the default route of the router is pointing it towards the private interface. The private interface doesn't go anywhere because it is a private VPC. It's a virtual private cloud. It doesn't go anywhere. It doesn't have an exit, because the reason to make sure that you do not advertise anything in that cloud. So right now it is pointing to the default. Default is pointing towards the VPC, which is the private cloud. So I'm just removing the default route from the interface, because it's now refreshing everything. It is taking a bit time. So it's saying that resources, it's taking too much resources because all the BGP sessions was already there. So, and that is the problem with the software-based routing daemon, right? So it takes a time. I mean, convergence is fast, but if you reset the session, it takes time. Well, and when you have 11 session with full BGP feed, it takes a lot of time. So yeah, right now I am on, I think, 4th router. So it is just happening. I fixed it, but it's just taking a long time. Probably 5 minutes. Okay, I have just restarted the router, so that is the easiest possible way. It will fall back to the previous configuration, and all should have our routers back.
It was my lab during Epic City recruitment.
Mhm.
It was my lab, like my lab means like connecting it with the routing network.
Oh, really?
Yeah. And checking the ballots and ballots.
I've got two of my environments set up here for a demo.
Will you be able to finish it on time? Because I felt like we were behind. What is the total usage?
Okay, so we are back. Okay, tell me which router having problems? Okay, I'll change one by all of them one by one. So just give me a moment. Starting from 4. All right, should be back for all of you. Please have a look. If it is still not, let me know which router you have. So are you able to access your routers now? Okay. So have you enabled the RPKI? No, just point towards the routinator. Yes. Yes. Yes, you can point to two of them. Yes, let me show you.
No. But the other platform that does something like this guy, just simply takes the umbrella down the fence. But if you wanted to leave the nickel that I have, or if you want to turn it into the flexible controllers, that's really. Universe is a reason. Universe you can turn around this. Instead of seeing us use it. But you don't have to send it. But there was something similar in the brains, but it's just it's
And you need to better black on India, just.
Automatically, whatever
That is good for getting from other options. That can-
use things. I mean, since but then some various natural research.
All right. So the two things you have to do once you have the access, one is that you enable RPKI in your router and then point it towards the RPKI relying party software. So there are two relying party software. One is using Routinator, the other one is using Fort. You set the preference. The lower preference is better. I mean, whoever has a lower preference will be connected first, and the other one is a fallback just in case it is not working. So there are two. The Routinator is using 83323. Fort is using 8323. So you can use any of them. Once you start the validation, for example, I have just enabled it here. Too small. Okay. So once you enable it here, then you can do you can see that which one it is connected to. So one, it is connected to one of them, right? And then you can check if you are getting the cache. So the best way to do it is you do show RPKI AS number 139038, and it will give you all the ROAs you have received from the cache for that particular AS number, right? So you enable that. So which I have done here. So I can do show RPKI AS number 139038, and it will show me the same result on this router, right? It can also show me RPKI, show BGP RPKI invalid. Okay, so I have not enabled anything yet on the BGP side, so I have to enable it. So for that, what you have to do, you create this. You create a route map, and then you tell what to do with the valid, invalid, and not found, right? So if it is not found, then you can say, well, reduce the local preference. Higher is better, right? Local preference, higher is better. If it is valid, then of course you increase the local preference. And if it is invalid, then you can either drop it or you can decrease the local preference. And then you just go and implement it, apply the route map to your BGP pair. Then it will start enforcing the RPKI cache outcome, right? Simple as that. Could tag the validated routes with a specific community and the not found ones with another community. You can, I mean, it's a route map. You can do whatever you want on the basis of the validation. If you think that you don't want to drop it right now, you can just reduce the local preference, or you can attach a community, or you just don't do anything and just observe that how many invalids you are receiving and talk to your customers and try to fix it. If you are receiving it from your transit provider, well, there is nothing you can do about it. Right. So the lab is available for next 24 hours. I will make sure that it is available. You can do it now, right now. The time is, we have a few more minutes. You can do whatever you want right now, but I just want to give you a couple of more details which help you. Well, we can't implement it in the lab because they are not standardized yet, some of the features, but we can discuss about them. I will upload the presentation, so you'll get all the snippets which you can implement as well. Lab is available next 24 hours. Next tomorrow, if anybody needs the lab for another day or two, just let me know. I will keep your router enabled and not shut it down. Now, I told you one thing. One thing was RPKI is a framework. ROA is one of the options to use the RPKI. Okay? There are other options which you can use for you can use with RPKI. Number one is ASPA, which is called AS Path Authorization. Just like ROA, which helps you identify or validate the origin of the route. ASPA helps you with the AS path, right? It can help you only, or our ROA can help you. ROA can only help you with the origin. It doesn't help you if someone, with the example we gave before, Terry was talking about, that if you start prepending an AS of somebody else with a valid ROA, then of course you can hijack that prefix, right? But if you have an ASPA object attached as well, then the AS path will fail, because of course you are putting your own ASN in the middle and creating a fake AS path. It will fail. ASPA, unfortunately, is still a draft at the moment. It's not a standardized yet, but there are some test implementation. I wrote a detailed blog post on it on the Manners website. You can have a look and see for yourself. There's another one called AS Cone. Again, it's still a draft. There is another protocol. It's an enhancement of BGP called BGP sec, right? It adds more complexity to the BGP. It adds the crypto verification into the BGP. Right now, what is happening? BGP is not doing anything. BGP is not looking after the crypto part. It is not looking after the certificate. It's not reading the certificates. It's not doing anything with the certificate. It is only talking to the relying party software or the validator. Validator is getting the certificates, reading it, creating a cache, and handing it over to router. Everything is happening outside the router. BGPsec moves everything inside the router, right? Of course, that means it requires more resources. It is a bit resource hungry, but it gives you end-to-end verification or validation, right? It checks every path, every path. Of course, everybody has to implement BGPsec for that. Of course, if I'm not implementing BGPsec, you are, and we pair with each other, we will fall back to the normal BGP. It will not work. So it is theoretically very strong protocol, but requires more resources, and implementation might take some long time. But it's been standardized as well. So this is the, I just want to go to the, is the AS set. ASPA, right? So I just want to go to the ASPA, right? Before I go to the ASPA, I just want to explain what is AS set. AS set is another object in IRR, in the WHOIS. It's another object. What it does? It creates an object, just a name, which tell everyone that how many members you have in your downstream, how many customers you have in your downstream, right? So for example, if I create an AS set with my AS number and then give it like AS139038 : customers. So it defines all the customer I have. So I put their ASN in the member list. I create a member list saying these are all the customers I have, and they will be announcing something. What? I'm not telling you that. I'm just saying these are my customers, AS numbers. And then when you try to create a prefix filter on the basis of AS set, it will recursively look up all the AS and their route objects. So what it will do, it will look up every AS, go to the IRR database, look up all the route objects for that AS, and create a filter list. Second member, go find all the data, update in the filter list. So let me give you an example of that. For that, we use Okay, so let me just install it. BGPQ3. It's a tool. You can install it in any Linux distro, or there's a newer version called BGPQ4. You can use it as well. So what it does, BGPQ3, and I just write my AS number, AS1390338. What it will do, it will go to, by default, it will go to RADB. I can specify that just go to the APNIC host database, and it will generate the prefix list automatically for all the resources under this ASN, which has a valid route objects. Okay, so it has created one because I have one route object, valid route object. So it has created one, 103.138.210.0/24, right? So if someone has a bigger one, big service provider, they can create filter on that basis. For example,
Stucky. AS-Stucky works.
let me,
Or 1221.
too big.
Too big? Okay.
Okay, that's my previous employer. So it's always handy.
That's big.
So it just created a prefix filter for all the prefixes which has a valid route objects under RADB, right? Just did it. Now I can also this is me. Okay. How many of you are aware of peering DB? Anyone? So peering DB is a database of all the ASNs, which gives you how they are peering, what are they doing, blah, blah, blah. It gives you a lot of information. So the information I'm looking for here is the AS set. Okay. So I come here, it says Vocus AS set. Vocus is the second largest or third largest service provider in Australia, or I would say in the region, in the Oceania region. So I just picked up their peering AS set, came here and asked APNIC to provide me the details. So they said, well, AS set is there. They have one member and another AS member. So it's a cascade. So I looked up this one, then I say, okay, fine, because this is going to be a big one. See how many members they are there. All their customers are here. So if I use BGPQ3 with this AS set, I am not going to press. So it will take a long time, but it will create recursively. It will keep on going inside to inside and inside and inside and build a prefix filter, probably 200 or 300,000 lines long. That's why it's not giving me anything. It was taking so long. Yeah, so let me pick a smaller ASN. Again, AS9541. Right? So they have not many, right? Let's see how long it take. Here you go. So right. So what so it has created a prefix filter of how many lines? 1,444.
Yeah.
It is a relatively smaller service provider. I mean, it is third or fourth largest service provider in Pakistan. But compare it with Vocus, it is very small. With a small service provider, the lines are 1,444. And if I do it for Vocus, pretty sure it will be more than 100,000.
Yeah.
If I add Telstra, I'm talking about 200,000.
Yeah.
If I do add PLDT, more. If I add a couple of more customers, I'm talking about 4 or 5 million lines of prefix filters. Can I implement that in any router? No. Well, I can, but it doesn't scale. How many times do I have to update that? Because everybody wants to change their filters. How many times I have to update that? Well, people do implement it, yes, in their routers, but it doesn't scale. So you can do it with every customer, of course, but you cannot implement it. You can do it with your downstream customers, yes, because it's per customer, it's one filter list, but you cannot do it on the transit where you're receiving up to 1 million routes. You can't do that on this one. So you can do it with the downstream customers. So this is for the downstream customers, your own customers. You can ask your customer to create AS set. And if they update their AS set, their filters will be updated automatically, but you can't do it on the transit, right? You can, it's very hard to do it on the peering fabric, but if you're doing bilateral peering, it's easy. But it doesn't scale. And that's what I was trying to show. So that is the problem with the AS set. So it's giving the example BGP Q4. You can install BGP Q4 as well. By the way, using BGP Q3 or 4, you can generate prefix filter for Cisco, for Juniper, for MikroTik in the newer version, or Bird as well. So you can create it for anyone.
And OpenBSD and Huawei. Yeah.
Now, fast forward it to ASPA, right? An ASN list that ASNs it will use as transit or with whom it has relationship. So what it will do, what you can do that if you are buying transit from your upstream, you can literally define that I am this AS and my upstream is this AS. If you are peering, you can define I'm pairing with this AS, so my AS and this AS. So you can create your paths. So this is my path. It will always remain as it is. If the path changes, do not accept that. Okay? So transit-free networks, nothing. It's only one. There can be multiple relationships. So you can define your relationship with every ASN you have. And I think I can show you. Right. So this is an ASPA object. So this is what it is saying. Just read this one, nothing else. I mean, all the information, I mean, it's fine, but you don't need to read everything. It is saying that 945 AS number 945 has a provider set, which has a private provider relationship directly connected with 1299, 6939, 32097, 50058 and 61138. This is the relationship structure they have created. So let me take this here and connect it to, how many of you are aware of route views? Anyone heard about route views? Yes, no? These are publicly available routers. You can log in and find a lot of information.
Yeah. Okay.
Sometimes they are slow.
Maybe we can come here.
And right now it is slow. So let's see what it says about the AS path it is seeing from the global routing table and multiple sites. So I've just used a regex and just find out what it is saying. Well, it is only announcing it directly. 945 is 7480 3491. Well, interestingly, that part, that path is not here. Well, what can I say? So at least 945 is connected to 6939 because 6939, this is 6939. This is AS 6939. So here it says that I'm connected to AS 6939. So at least it is showing here. But it is not connected to anyone else as per the route views, Hurricane Electric route views, route server. So you can create your relationship. You can create your relationship, and if this relationship changes, and it is not in the ASP object, and you are validating on the basis of ASP object, you can simply deny. You can drop that. It means probably someone is trying to hijack the path, right? If it shows up with another AS which has no relationship as per the ASP object, you can simply deny that, right? This is a draft. It is not a standard right now. Few people have implemented a test code. So it is early, but the concept is exactly the same as ROA. ROA is about origin validation, prefix versus origin. ASPA is only about the AS relationship, AS path authorization. That's it. I am authorizing through my ASP object that I will be coming from this path. Now, but I mean, they literally have to steal the whole path. They can't, right? So it makes it almost impossible to do that, right? Unless they are pairing with one of them directly, and then they try to insert themselves there. But then yes, you are minimizing the what you call it, the blast radius, right? So you are making sure that they're very small likelihood of anything happening, right? So it gives you extra security just to make sure that not only you have secured yourself from the route origin misorigination from somebody else, you also have secured yourself from the path manipulation. Okay, so final consideration, run multiple validators. As you can define two multiple sequences. You can define the preference. You can say my first preference is this validator and the second preference is this validator. If something happens to the first one, you can always fall back to the second one. The choice is yours, whichever relying party software you want to use. I showed you I'm using Routinator and Ford. They are absolutely fine. You can also use RPKI client. I have recently started using RPKI client. It is very lightweight as well, just like the other ones, but it's up to your own choice. The most important bit is monitor your network from outside, right? For your BGP feed from outside. For example, there are certain commercial operators. They are sponsors here. For example, Kentic. They give you a lot of information from outside that how your network is behaving. If someone is trying to use your AS number or someone trying to use your prefix, or you can use an open source one called BGP Alerter, right? It was written by Massimo Candela. He works for NTT. He was the Manners Ambassador last year. And very actively working on this one. He has also created a free web UI version called PacketWiz, packetwiz.io, or yeah, I think it's packetwiz.io. We can quickly look. Packetwiz.com. So you can go to packetwiz.com and you can create your own login. It's free, and you can add up to 3 ASN for monitoring, right? So you can add up to 3 ASN for monitoring. I cannot show you my login because it has a lot of ASN. You can add up to 3 ASN in it. It's free of charge. Put your own ASN, monitor your own ASN, not anybody else. So it will show you if something changes on the internet. If your route suddenly disappear, you will get a notification. If you have a invalid, if you somehow made invalid route object or invalid ROA, you will get a notification. If any of the RIRs, trust anchor locator, is not available, it will send you a notification. Anything changes, good or bad, you will get a notification. So sign up for PacketWiz. It's free, and you'll get the notification. So that is the most important bit. Make sure that you use route views. If you haven't signed up for Manners, sign up for Manners. It's free. If you are implementing RPKI, if you are doing the route filtering, sign up for Manners, and you will get the Manners observatory access as well. We collect the same data from different places and give you the same result as well, again for free. So choice is yours. Any question you have, more than happy to answer. As I said, lab is available. You can use it till tomorrow. If you have any questions, please go ahead. Otherwise, we can talk during the lunch break. Yes. And there are, again, multiple suggestions for that. You can use same relying party software running 2 instances, right? Here. So it's always the same cache, right? So it doesn't change. I mean, if someone is implementing something differently, so it doesn't impact you, you have the same cache. It's just 2 instances. If one goes down, it's a software, it can crash, right? If one goes down, you still have access to the other one. And even if the server is not available, it's a cache. You still have the cache, right? So you can still, it doesn't break anything. And if the cache disappears, if the server is gone, nothing is going to break, because it's still, you're not dropping the not found. Yeah, you're not dropping the unknowns at the moment, right? So you're only dropping the invalid if you are. So it's not going to break your routing. So it's still quite safe at the moment, but it's better to run 2 versions of validator. Now, there are always updates coming in for these relying party software. Do have a look at that. Update your softwares. Don't just leave it. Install it once and forget about it. It's just a piece of software. It requires update. Treat it as a software, right? So, and the reason why there are so many updates coming in, because the technology is still sort of new, and every now and then you see some bugs coming in and the fixes comes up. So you have to update them. So this is where we are at the moment. And now the last most important bit, the questions. If Terry can help me with at least one question, come up with a question, and then we can distribute these gifts to all of you. So the first question is, what are the 2 reasons which can mark your route invalid? Yes, perfect. So number 1 is the length and the other one is the origin. All right. Second question. Let me think about the question. Or I can read it from my notes, which is a much better option. Yes. Can you name what is the protocol which relying party software use to talk to the router? Abbreviation? Yes. Okay, and the last one is, what changes were made and which RIR made those changes to install the trust anchor locator without any restriction? Not applicable to APNIC or ISOC staff. Okay, which RIR made a change last year so that you can install the trust anchor locator without any restriction? Anyone who has answered it is already disqualified for answering again. Okay. Yes. All right. So that was the last one. Thank you so much. Okay. Now, all of you, do not forget to collect your T-shirts from the manners booth after the lunch break. Right? So until then, thank you so much. I hope you learned something. At least I learned something, that I need more RAM on the core router so it doesn't crash. 8 GB was not enough. I mean, for the edge routers, 2 GB was enough, but not for the core router, because 15 full routing table, that was something. So something to learn every time. But anyway, lab is still up. Everyone has converged. So router is breathing properly. The filters are implemented, so you can play around if you want to. When you go back to your hotel rooms, and if you have time, you can play around. It will be available until tomorrow. If you need another couple of days, please do reach out to me. And I'm here for the whole week. I will not turn off your router. Otherwise, I will turn off everything by tomorrow. Thank you so much. Thank you, Terry, for helping me around. And I'll see you again. Don't forget to come to the routing security SIG. We'll be talking about other AS set information, that how it is vulnerable to the attacks. Here you go. Thank you.